This video is going to show you how to multiply a decimal and a whole number. So we're going to do 4 problems together, and what I'm going to do, I'm going to show you each of these problems with the estimation and with the correct product. That way you can check for reasonableness. So the first problem that I want us to work on is 9 and 8/10 times 2. So if I'm going to do my estimating first, when I look at 9 and 8/10, I think what I'm going to do is I think I'm going to do some front end estimation, okay? Or whole number, round to the nearest whole number. That would be the same for both of these. So I'm going to take my 9 and 8/10 and I'm going to round that to the nearest whole number, okay? Which would be 10. Now, I am very friendly with 10 and with 2, so I'm going to keep my 2. So that tells me that 10 times 2 is 20. So my estimate is 20. Now, I know that in order to go from 9 and 8/10 to 10, I rounded up. Okay, I did not round this number at all, but I did round this factor up. So that 20 should be close to the real answer, but it's going to be over the real answer. Okay, that'll help me because if I get an answer of, let's say, 21 and 3/10, but this says that 20 is too much, then this cannot be my answer because 20 is already too much. So I'm going to treat my 9 and 8/10 times 2 as if it was a whole number. Okay, I'm going to forget about this decimal. I don't want to deal with the decimal right now. I want to deal with the decimal at the end. Okay, so really it's like doing 98 times 2. And then I just multiply it just like it's a whole number. So 2 times 8 is 16. 2 times 9 is 18, plus 1 is 19. So 98 times 2 is 196. And now I deal with the decimal. Now, what I mean by that is I count over how many places that decimal is, and then if both factors have a decimal, I do the same thing, and then I put them all down here, okay? What I mean by that is this. This decimal is over one place. This factor does not have a decimal. So that means that in my product down here, I need to go over one decimal place for the decimal point, okay? So 19 and 6/10. This is why it's super important to do this estimating today, because I can look here and I can say, yes, 19 and 6/10 is very close to 20. That is a reasonable answer. But if I were to forget the decimal, and let's say I did have it as 196, well, if I see 196 and I know that my estimate is 20, and that 20 was too much because that was an overestimate, then something is wrong down here. And that should be your clue that you should look for a decimal, that you probably forgot to put a decimal, okay? Same thing, let's say you have your 196 and you accidentally count over too many places, okay? Let's say you counted over 2 for some reason. Well, if I have my decimal 2 places over right here, and then this becomes 1 and 96 hundredths, hopefully looking at that estimate, I will say, well, yes, I know 20 was over, but 20 and 1 and 96 hundredths are not close together. And so again, that should be your clue. Double check your decimal, okay? So let's do another one. This time I have 67 hundredths times 8. All right, so thinking about what we did the other day with our rounding of the decimals, okay? If this is 0 and this is 1, the midpoint is 5/10, okay? Well, if I'm placing 67 hundredths, that would be maybe about right here, okay? So 67 hundredths is really close to 5/10, to a half. So I'm going to call this 5/10. I was using compatible numbers, okay? And then remember, if I'm multiplying by a half, multiplying by half is the same thing as dividing by 2. So what is half of 8? Well, that would be 4. So my estimate is 4. Now, I didn't change the 8 at all, but over here, going from 67 hundredths to 5/10, I went down, right? So this is an underestimate. So that means the real answer has to be close to 4, but it's going to be higher than 4 because 4 is less than the real answer. So again, I'm going to write it as a decimal, but I'm really going to think about it as just whole numbers. Forget that decimal is there, okay? Don't even think about it. So really right now we're doing 67 times 8, and we'll deal with the decimal at the end. 8 times 7 is 56. 8 times 6 is 48, plus 5 is 53. Okay, so I know 67 times 8 is 536. But look at this. My estimate is 4. My answer is 536. I should say, oh no, there's something wrong, and then go, oh yeah, there's a decimal. So I'm going to start here on the right, and I count over, and this time this decimal is 2 places over. This factor does not have a decimal. So that means that I need to put my decimal in my product 2 places over. So I start on the right and I go over 2 places. So I'm saying that my product is 5 36 hundredths. So again, evaluate that with your estimate. Is 5 36 hundredths close to 4? Yes, it is. And remember, 4 is an underestimate. So 4 is under 5 36 hundredths. Okay? Again, if I did this and I accidentally counted wrong, and I have a decimal here, okay, instead of my 2 places, let's say I only went over 1. If I see 53 6 hundredths, and I see the estimate is 4, and I say to myself, oh no, that is not close, then what you need to do is go back over here and count your decimals again and make sure that you have them 2 places over. All right, I'm going to clear this whole thing. Let's do another one. This time we're going to do 34 times 5 3/10. Well, I don't know about you, but 34 is not very friendly to me. I'm going to round that to 30. Okay, and I know that that means I went down some. Okay, and 5 3/10, that's not very friendly either. Okay, so I'm going to do whole number, round to the nearest whole number, okay, or in this case, it's also front end estimation. So if I look next door, 3 is less than 5, so 5 3/10 is closer to 5 than it is to 6, okay? And again, I also rounded that one down. So that tells me that my estimate here is going to be an underestimate because both factors were rounded down. All right, so then I just do my fact. So 3 times 5 is 15, and I have 1 0 left. So my estimate is 150, but again, this is an underestimate, so it has to be close to 150, but it has to be more than 150 because this is under. All right, so I write this just like I would any other whole number multiplication problem, okay? I forget about the 0, so it's really 34 times 53, okay? So 3 times 4 is 12. 3 times 3 is 9, plus 1 is 10. I'm going to cross this off so I don't use it again. I'm also going to cross off my regrouping so I don't get mistaken. Now, this 5 is, if we're forgetting about the decimal, this is in the tens place, right? So I really need a 0, okay? because I'm going to my next row. Now 5 times 4 is 20. 5 times 3 is 15, plus 2 is 17. And now I add. Okay, so 34 times 53 is 1,802. Okay, and if I look at this and I look up here, I should say, oh no, there's a problem. This 1,802 is not close to 150. That's because I still have a decimal place here. Okay, so I start on the right, I go over, and that's 1 decimal point. There are no decimals in this factor, so I don't have to worry about that. That means that in my answer, in my final product, I need to go over 1 decimal point. So this answer is 180 and 2/10. Now, is that close to 150? I would say that that's relatively close, yes. And remember, 150 is an underestimate, so is 150 under 180 and 2/10? Absolutely. Okay. Last one together. 34 and 6/10 times 21. All right, so if I look at this, oh my, 34 and 6/10. That is definitely not friendly. So I have a couple of options. I could change this to 30, okay? And that would be my front end estimation, change it to 30, because looking next door, that is less than 5, so this would be 30, okay? I could also, I'm looking at this, and I actually, when I first looked at that, I thought about money. I thought about $34.60, and I know that that's really close to $35, okay? That part that I just did there, that's rounding to the nearest whole number. Okay, so if I round to the nearest whole number, it'll be 35. Okay, so this was front end, and this was whole number. Either one of those strategies is useful today. Okay, now I'm looking at 21. 21, definitely not very friendly. So I'm going to round to the nearest 10 here. Okay, and I'm going to call that 20. Okay, so really my only difference here is it looks like since this was rounded down and this was rounded up, it looks like if I do both of these that my real answer is probably going to be somewhere in between these two estimates. So for this, I do the fact, 3 times 2 is 6, and I have 2 zeros. So 600 is this estimate using front end estimation. 35 times 2. Well, remember, 35 times 2 is the same as 35 plus 35. So that would be 70. Okay, now I have not used this 0 yet, so I do have to put it here. Okay, so again, this is an underestimate, this is an overestimate. So that tells me that the real answer to this problem has to be between them. Okay, so 34 and 6/10 times 21. Again, I treat it like there's no decimal there. I wait till the end to deal with the decimal. So it's 346 times 21. 1 times 6, 1 times 4, and 1 times 3. And then this 2 is in the tens place, so I place a 0. 2 times 6 is 12. 2 times 4 is 8, plus 1 is 9, and 2 times 3 is 6. Add them together, and I have 7,266. Well, again, if I'm looking for something that's between 600 and 700, 7,266 is nowhere near that, okay? Because I didn't deal with my decimal yet. So I have to count over one place. This factor does not have any decimals. So I only have one place in my product to go over. So the real answer here is 726 and 6/10. Now, I just realized I did something wrong. So up here, we did round this down, but if I round down, doesn't that mean this should be up? What did I do there? Let's see, if I round this down, oh, you know what? Here's the key, here's the issue. I didn't say for these 20s, remember I rounded 21 to 20 in both of these? I didn't say whether they were up or down, and so that changes this just a little bit. Okay, so before we did this, we were thinking, oh, it has to be between 600 and 700, but we didn't take into account that extra group. Okay, and that does kind of change things a little bit. So I'm looking at my real answer, and my real answer is close to 700. Okay, and so that is a reasonable answer. And if I did the front end estimation, that would still be a reasonable answer. 600 is still relatively close to 726 and 6/10. It's just that the 700 estimate is much closer.